Dear ladies and gentlemen, good morning to our Dutch audience and good afternoon to our Chinese audience. Welcome to our dialogue on industrial electrification between China and the Netherlands. We're delighted to see participation from academia, government, and business industry on such an important topic. Before I start, I'd like to remind everyone on the interpretation button in the lower right corner and select a language. Otherwise, you won't hear the interpretation. My name is Tom van Beek, and I'm the host of today's webinar. I'm working for the Netherlands Innovation Network in Guangzhou, China. This webinar was originally planned to be hosted from Shanghai, but due to the risk of traveling, we are now hosting it in Guangzhou. However, I am being supported by my colleagues Marita Mitrovic, David Beckers, and Fons Klein-Tuente, also from the Netherlands Innovation Network in Shanghai and Guangzhou. Within the Netherlands Innovation Network, we focus on establishing long-term research and development collaborations between businesses and research institutes in China and the Netherlands, mostly on innovative topics, often related to societal challenges. We are located in the embassy and consulate in Beijing, Shanghai, and Guangzhou. Of all the fuel that industrial companies use for energy, McKinsey estimates that almost 50% could be replaced with electricity using available technologies. However, technologies continue to improve, becoming more efficient and cost-effective. Electrification of the industry also relies on other factors, like lower power prices and the right supportive regulations. This is why it's important to involve all stakeholders, also internationally, in dialogues like these. This is our first event on industrial electrification, and we will stay connected to this topic and other related topics in the near future. If you would like to stay involved, please stay in touch with us personally or follow us on LinkedIn for follow-up events. Before we start, I would also like to take a moment to mention that this is a very special year, as the Netherlands and China have 50 years of diplomatic relations. In those 50 years, there have been lots of successful collaboration between the countries on both diplomatic, economic, and research level. These collaborations are important for both countries as both sides benefit from working together. Therefore, we strive to keep this successful collaboration ongoing and hope that this webinar can contribute to that goal. Today, we have an interesting program with various speakers focusing on industrial electrification. We'll explore the ongoing developments in China and the Netherlands and the direction the industry should be heading in. After the keynote speeches, we'll have an interactive panel discussions with experts from across the sector. Both the policy, business, and research sides will be represented, as all these parties play an important role in the emerging market. We will start, however, with two opening speeches from both the Chinese and Dutch policy side. But before that, on a practical note, the first 45 minutes of this webinar consist of a pre-recorded presentation with subtitles. The speakers will be present and available for questions. They will turn on their cameras during their pre-recorded presentation. We have chosen for this format to make the experience as comfortable as possible for both sides. You can ask the questions to the speakers using the Q&A option below. Feel free to ask questions in both English or Chinese during the webinar, as the questions will be translated. Some of the questions will be answered in the chat by the speakers, and others may be addressed at the end during the Q&A. Afterwards, with the panel discussion, it will be live with simultaneous translation. We recommend everybody to type their questions during the panel discussion in the Q&A so that our translators have the opportunity to provide us with a translation. If you wait with typing your questions till the end of the panel discussion, chances are that we're not able to address them during the panel discussion itself. If you have questions for a specific panelist, please mention their name in your question so they know they have to answer it. For now, please allow me to present with great honor to respect the speakers that are with us today. Each one of them plays an important role within the field of industrial electrification in China or the Netherlands. I'm starting with the two opening speeches. The first one by Mark Smets. He's the team lead of chemical industry and innovation at the Dutch Ministry of Economic Affairs and Climate Policy. And afterwards, Yongliang Li, Deputy Director of the Department of Industrial Development at the China Petroleum and Chemical Industry Federation. The opening speeches are followed by Erik Appelman. Director of Business Development at Brightlands Chemelot campus, who will give a presentation about the development in the Netherlands and the techniques developed at their campus. Then Shunyi Li, Manager of Industry Decarbonization at RMI China, will give a presentation about the key findings of their study on electrification of the chemical industry in China that is going to be released later this year. And last but not least, Reinier Grimberger, Principal Consultant Business Development at VoltaChem, will go over the prerequisites necessary for successful collaboration, the opportunities which can make the biggest impact, and the role VoltaChem plays within this area. Feel free to ask the speakers the questions in the Q&A below during the presentations. The questions will be translated and the speakers can answer them in the chat. Now, with further ado, let's start with the opening speeches. Mark Smets, the floor is yours.
Dear participant, I'm more than happy to open today's dialogue on industrial electrification. The global environmental crisis, such as climate change, the plastic soup, the biodiversity losses, they are all interrelated and require firm leadership from governments, the private sector, and not to forget ourselves as consumers. And to address these challenges, Europe has announced a Green Deal policy. All 27 EU member states are committed to turning the EU into a climate-neutral continent by 2050. And this is translated at national level in the Netherlands to a 55% emission reduction for 2030 and 80% in 2040. The electrification of the economy and the greater use of renewable energy is an important pillar in this European Green Deal and the national policy in the Netherlands. Already 4 years ago, our ministry changed its name from Ministry of Economic Affairs to Ministry of Economic Affairs and Climate Policy. And actually, that describes a lot. We value quality of economy over volume. In the Netherlands, we have intensified over the past few years investments and collaborations to develop the use of electricity to generate heat, to use electricity to make chemical transformations via hydrogen, and to use electricity for direct chemical transformations via electroconversion. To accelerate innovation and upscaling of industrial electrification, we have national platforms in the Netherlands. One for energy and industry and one for electrochemical conversion and materials. And these platforms are perfect vehicles for international collaboration. Moreover, and I'm happy to announce this spring, one of the largest innovation programs the Netherlands has ever had will start. And this program is in the field of power to chemicals and power to hydrogen, and will seek opportunities to collaborate internationally as well. Last October, we sent our roadmap for industrial electrification to Parliament, and our new government, that's actually started last week, announced large investments and new regulations to meet the ambitious climate targets and to turn the innovation agendas into practice. Heading for industrial electrification also accelerates cross-industry collaboration and innovation and leads to the creation of new business opportunities. Both China and the Netherlands have large chemical parks with heavy industry in which projects are underway that deal with electrification. Imagine, for instance, the importance of power to hydrogen for the Netherlands. With 16.5 billion cubic meter per year, the Netherlands is the second largest hydrogen player in Europe. Today we have some interesting keynotes to gain more insight into the Chinese and Dutch approach towards electrification and to give examples of best practices in both countries. It is a great opportunity to exchange today the experience we have in the Netherlands with working towards electrification of our industry and to share our experience with Chinese companies and knowledge institutes. Let's work together on this challenging task to electrify our economy and our processes. Let's work together on this 21st century disrupting transition, because that is what it at the end is. I hope you enjoy this meeting. Thank you.
Thank you, Mark Smets, for these nice opening words. And now we are transferring to the second opening speech by Yongyang Li, who will now get the floor.
大家好，我是来自中国石油和化学工业联会的李永亮，非常感谢本次会议主办方 荷兰大使馆创新网络的邀请，能够有机会参加中国荷兰工业电气化对话会议。这是一个非常宝贵的机会，可以与各个机构讨论通过提高电气化率、增加使用可再生电力来降低工业碳排放量的路径，以及在这个过程中可能产生的发展机会。化学工业是非常重要的一个工业部门，中国和荷兰都有一定规模的化学工业，都面临着节能和减少碳排放的压力。中国化学工业销售收入占全球大约是40%，是全球化学工业非常重要的一个组成部分。2020年，中国正式提出碳达峰、碳中和的目标，中国的化学工业也将为实现这个目标而贡献力量。中国正在陆续发布碳达峰、碳中和1+N 系列政策。中国已经发布了关于完整、准确、全面贯彻新发展理念，做好碳达峰、碳中和工作的意见和2030年前碳达峰的行动方案。那么还将陆续发布能源、工业、建筑、交通等重点领域和煤炭、电力、钢铁、水泥等重点行业的实施方案，出台科技、碳汇、财税、金融等保障措施，这样形成碳达峰、碳中和的1+N政策体系，明确时间表、路线图和施工图。那么涉及到化工行业的相关政策，也会在相关的政策文件里头包含其中的。工业领域碳达峰行动也专门提到了要促进工业能源消费的低碳化，推动化石能源清洁高效利用，提高可再生能源应用的比重，加强电力需求侧管理，提升工业电气化水平。在化学工业碳达峰、碳中和众多的方向之中，电气化是非常重要的一个方向，但如何提升电气化率，还存在着不少的挑战。科技装备、电网的适应性改造、商业模式的开发等等，都存在着一定的这个挑战或者是障碍，这些都需要进行探索和示范。我们非常期待今天这次会议能够为中国、荷兰化学工业的电气化工作提供观点，提出方向，探讨可能出现的机会。最后呢，再次感谢本次会议的主办方荷兰大使馆创新网络的邀请，谢谢大家。
Thank you, Mr. Lee. I'd also like to thank you for your opening words. We will now start with the first keynote speech by Erik Appelman, Director Business Development at Brightlands Chemelot campus, who will give a presentation about the developments in the Netherlands and the techniques developed at their campus. Feel free to ask questions in the chat as Erik is available to answer them. Thank you. Erik, yours.
My name is Erik Appelman. I'm a director of the Brightlands Chemelot campus, where we do upscaling of a great variety of new technologies for the chemical industry, predominantly aimed at a sustainable future. It is my honor to be speaking to you, and I will happily share a small presentation with you. First, a few words of introduction of myself. I'm 57 years old. I was trained as a chemical engineer in the distant past. I did army service and I worked with a variety of companies in the chemical industry, and I was heavily exposed to both engineering side and product development sides. I bear good memories of China, where I led a paint development laboratory in Kunshan, which is today owned by PPG. As I told you before, I'm working at the Brightlands Chemelot campus, which is a wonderful initiative of a regional government, a provincial government in the Netherlands, a local university, and a big corporation that has deep roots in our region, the multinational company DSM. We are home to companies that scale up all sorts of innovative technologies, and with a particular emphasis on scaling, maybe a little bit more than fundamental research. We do not have a university presence in a very big sense, but we predominantly concentrate on upscaling in what is really an industrial environment. We offer all kinds of facilities, laboratories, clean rooms, offices, you name it. But we offer them also for commercial tariffs. In other words, when you come with us, you have to behave like a real company and not like a research fund. Hot topics in our agenda are recycling, plastic waste, electrification, biomass feedstock. Also some very interesting topics in the biomedical domain, like cell therapy, cell and tissue growth, and mRNA manufacturing. We also do additive manufacturing and design of products. In 2012, and today we have no less than 3,000 professionals working here every day in more than 100 companies and institutes. And on top of that, there is also 1,200 students. We are financially autonomous because we really run this like a business. We are closely connected with one of the largest chemical industry parks in Europe, the Chemelot Industrial Park, which is right next door. We all know that the chemical industry is a very large contributor to greenhouse gas emissions, and there is no escape. We have to reduce those. We have to take our responsibility because the world has to survive in good order. We can change that by switching to electricity. And that is perfectly possible because electricity is a very versatile source of energy. Having said that, there are a few challenges because we are not used to that. Firing something was a lot easier than electrifying something. There are quite a few of these very high temperature processes, and they tend to be also the highest in volume. Think of steam cracking of naphthas. Think of steam reforming. Think of steam methane reforming. And there is also cement and iron production, which are strictly speaking also chemical processes. Now, how can we then deliver that high temperature heat from electricity? Well, there's a couple of technologies, and I want to run through that, and you will find some interesting things about where we're doing and how we are doing that. A spectacular one is plasma technology. Equally spectacular one is shockwave technology. A little bit more traditional is resistive heating. There is radiative heating, and then there is even electrochemical technologies where we actually change the reaction mechanism by moving away from hot conditions to direct electrical conversions. Now, because that is then no longer a high temperature process, I will not discuss that in any detail further, but I can assure you that quite a few places in Holland do good work on that, among others at TNO, from which you heard a little bit in the previous speech. Let me talk plasma heating technologies first. This is actually an old technology. This is about letting gas be ionized by a very strong current that passes through it. You get temperatures of more than 1500 degrees C. And the technology was used in the past. Some of these reactors, especially for the manufacture of acetylene, have been operating for 50 odd years. It is quite extreme chemistry because most reactions that we are looking at today do not happen at 1500 degrees C. And you may ask, do we really need that? It is basically for a new set of chemistry. But some of that chemistry is very relevant. The one that fascinates me a lot is to convert methane to acetylene, because what you are doing there is you're building up from 1 carbon molecules to 2 carbon molecules. And we all know that from acetylene, it is a short step to ethylene. And from ethylene, you basically access the whole chemical platform. A nice side of this, by the way, is that you produce some hydrogen as well. So that is a very interesting thing. You go from relatively abundant and often low value methane, natural gas, to very valuable C2 and hydrogen. Another one that I find very fascinating is conversion of carbon dioxide to carbon monoxide. And from there you can go basically everywhere in the chemical industry. Very fascinating as well, plasma reactors are relatively simple. They are low in capex. You can switch them on and off rather easily. And that gives interesting possibilities, for instance, to respond to fluctuating availability of renewable electricity. The Netherlands are quite strong in that. We always had a fundamental institute, DIFFER, at the Eindhoven University. But what we are very proud of at the Brightlands Chemelot campus is a new professor that has picked up this challenge of mobilizing plasma heating technology for the future of the chemical industry. And if anybody is interested, this is definitely the place to be. Another spectacular technology is called shockwave heating. What happens here is that you use electrical energy to accelerate a gas to speeds well above the speed of sound. And what you then do is you make sure that somehow that gas hits a wall. Often the wall is actually the gas itself at a much lower speed. And what you then see is that the molecules collide on each other, but because you are about the speed of sound, they cannot sort of move sideways. They just get extremely hot before they can move away. And you can have very sharp temperature peaks, up to 1,000 degrees and more. That is actually interesting because that is a familiar temperature domains for the reactions like steam cracking. One company that has pioneered this technology is Finnish startup company Coolbrook. That is a company that has settled at our Brightlands Chemelot campus and builds a sort of a big jet engine, I cannot compare it to anything else, where precisely that acceleration happens, where the collision on itself happens, and where the desirable reactions then occur. And that is a prototype that they are building. But another one is another interesting thing that is being facilitated by the Chemelot campus, is where a group of very large petroleum companies and chemical companies are working with two of the largest technology providers in the world, Technip and Siemens, and do that same process in slightly different form. So this whole shockwave domain is very well represented in the Netherlands and at our campus. A little bit closer to home are resistive technologies. This is about pushing a current through a metal or another conducting material, carbon or silicon carbide or whatever else. And we have a very familiar reaction. This is what you are doing when you are using your electric water boiler, or even when you had a classic incandescent light bulb. And what happens is that the metal or the conductor gets very hot, and that very high temperatures can be used to kick off certain reactions. It's nice to control, actually. You can just tune the current to achieve the right temperatures, and you can typically do reactions that we know. It can be direct. In that case, you maybe send the current through the tube of a reactor or a reactor wall, which then gets hot. It can also be indirect, where you heat something up, like your incandescent bulb, and where you then use the radiation to heat something that is a little bit further removed from that. Various companies are active in this field. And at Brightlands Chemelot campus, we are proud to host a German startup company, Cypax, which uses direct resistive technology, among others, for steam methane reforming. We also expect other companies to come, because this is sort of the easiest and best known technologies also in terms of engineering. In order to decarbonize our chemical industry, we must find a solution to provide high temperature heat without combusting something. The good news is it is well possible, because electric energy is versatile and can be used for that. But the work is not trivial. You cannot do it tomorrow. Substantial scale-up work is required, because we have to learn the tricks. We do have to also think about that challenge of continuous availability of electricity, and renewable electricity in particular. On the other hand, some of the new concepts may be flexible towards fluctuating availabilities of those, and then you might actually even help society by being a little bit flexible. In the Netherlands, we have a number of very exciting initiatives at various institutes. I hope I can leave you with the idea that the Brightlands Chemelot campus, where I have the honor of being working, is a particular hot place to do that. And should any of you be interested to explore what we are doing, you are cordially invited as soon as we are free to travel again. Thank you very much.
Thank you, Erik Appelman, for your in-depth presentation. I see a lot of technologies come by, and I think they really provide a bright future for industrial electrification. And I see there's also still a lot of growth possible, so that's also very positive. So thank you for your speech. And then we continue straight to Shuyi Li, Manager of Industry Decarbonization at RMI China. She will give a presentation about the key findings of the study they're doing that is going to be released later this year on electrification of the chemical industry in China. Shuyi, the floor is yours.
Good afternoon, everyone. This is Shuyi Li from RMI. First of all, I would like to thank the Netherlands Innovation Network for having me today at this very interesting workshop. And in this session, I would like to share RMI's analysis on industrial electrification, as well as its role to decarbonize China's chemicals industry. Before the presentation, I would like to have a 2 minutes introduction of RMI. So we are an independent institute founded in 1982 with the mission to transform the global energy system to secure a clean, prosperous, zero carbon future for all. Under this mission, we work to identify the interventions through comprehensive analysis and work with different groups of stakeholders to scale transformative change in the global energy system in the aim to cut greenhouse gas emissions by at least 50% by 2030 and to reach zero carbon by mid-century. Our focus is 2 things in 5 places. In terms of areas, we work in the fields of carbon-free power, mobility, buildings, and industry. And we also work to strengthen market catalysts in data transparency, climate finance, technology, capacity building, and education. And our work across critical global geographies include the US, China, India, Africa, Southeast Asia, islands, and so on. Our China program started in 2012, and we are registered as the only international NGO under the administration of National Energy Agency in China. And our target is to accelerate China towards its carbon neutrality goal. We actually conducted one of the earliest research on China's zero carbon vision. So this report is released in 2019 in the name of China 2050, a fully developed, rich zero carbon economy. So in this analysis, we demonstrated that it is technically and economically feasible to China to reach zero carbon by mid-century. And we also explored the potential of different solutions in various sectors. So before we dig into industrial electrification of the chemicals industry, I think it's very important to understand the challenges for China's industry to achieve the transition. The first challenge is that China has still relatively young production assets. Take the chemicals industry, for example, the average capacity age for HVCs and methanol are less than 10 years and only 16 years for ammonia, compared with a typical lifetime of 30 years of all of these production assets. So this would add to the challenge to avoid stranded assets throughout the process of the transition. The second challenge is that China's existing production is highly dependent on coal. And this is true not only for the chemicals industry, but also true for the steel, cement, and aluminum production. The third challenge lies in the high cost sensitivity of the primary commodities. Given that these harder to abate industries will require disruptive decarbonization technologies, which are still at higher cost. And this will add to the challenges of how to make these solutions economically viable. So despite these challenges, it is actually technically feasible for China's chemicals industry to reach zero carbon. In this form, we listed all the major drivers for carbon reduction, and this can be clarified into incremental solutions and disruptive solutions. Even we see that the incremental solutions are at higher technology readiness level with lower cost. We have to say that they can only achieve partial carbon reduction. If we want to make fully decarbonization, we need to rely on disruptive drivers such as fuel electrification, CCUS, green hydrogen, bioenergy, and so on. And among these disruptive solutions, fuel electrification and green hydrogen are very critical solutions. And these are also the topics we are discussing today, which is industrial electrification. But when it comes to technology readiness, resource availability, and economic feasibility, there are still a way to go, given that these technologies are relatively at higher cost, which means that a more effective market mechanism is still needed in place. When it comes to decarbonizing the chemical sector, our analysis shows that electrification is one of the most critical solutions, not only in the way of electrification for fuel, but it also plays a very vital role for electrification for feedstock. In chemicals production, we only require relatively low temperature in the range of around 300 to 600 degrees Celsius. So this would mean that electrification could be a viable technology option to provide the heat required for chemicals production reactions. And in terms of feedstock, green hydrogen coming from zero carbon electricity can act as the key building block for primary chemicals like ammonia, methanol, and so on, which will further build up the whole value chain of the chemicals industry. Our analysis compared the ammonia and methanol production routes in China today and 2050. If we look at this chart, we can see that even though green hydrogen from clean electrification represent a very minimum share of current chemicals feedstock, it can take up to 60 to 70% of the feedstock use by 2050 through a power to X route. In this regard, it actually means a very remarkable growth in electrification for feedstock. And our calculation shows that by 2050, we can have up to 31 million tons of green hydrogen in the chemical sector itself. And we actually already have some advanced cases of electrification in the chemicals industry today, not only in China, but also globally. Take the feedstock use for example, we can see that Sinopec and Baofeng are already taking actions. One very outstanding example from Baofeng Energy is that Baofeng is starting to couple green hydrogen for methanol production. So this is commonly, it is regarded as one of the most promising route to reduce CO2 emission from the coal chemicals industry. In the field of electrification for fuel, we can also see some very good pilots by BASF, SABIC, Linde, Shell, and Dow. In this regard, we are already seeing some R&D progress on steam cracking unit for ethylene production. So apart from the technical feasibility, we also think that it is economically feasible to adopt industrial electrification for China's chemicals industry decarbonization. One very remarkable contribution is from the collapsing cost of renewable electricity. Actually, in the past 10 years, the cost of solar PV has reduced by more than 80%. And we also have a 60 to 70% cost reduction from wind energy. And even when we look at the lowest prices we can get for renewables power, we can actually achieve very low prices as low as around $10 per megawatt hour, which is actually good enough for the power to X routes to be more economically viable than traditional routes. Apart from the cost reduction for renewables, we also project a very drastic cost reduction for green hydrogen electrolysis equipment. So this is an analysis done by Bloomberg New Energy Finance, which shows that even under conservative scenario, there could be a very sharp reduction of cost in electrolyzer to produce green hydrogen. And for China's case, even right now, China has already have economic advantage of the electrolysis projects. So these combined, we see that green hydrogen could see very drastic cost reduction in the future, which will make industrial electrification a very economically viable solution to decarbonize the industry sector. If we look at the chart shown on the slide, while we see the total cost of green hydrogen right now is close to $5 per kilogram, it could be as low as only $1.6 per kilogram in a conservative scenario. And actually, some analysis indicates that we can achieve a green hydrogen cost as low as $0.8 to $1 per kilogram. And this is mainly due to the cost reduction of not only the capex, but also the drastic cost reduction of zero carbon electricity. So in this regard, it would actually mean that the major chemicals production like ammonia and methanol can go through a very promising cost reduction. For ammonia decarbonization, we compared different decarbonization routes and concluded that while CCS is more attractive in the short term, electrification and green hydrogen might be more economic in the long run. If we look at the chart on the left-hand side, green hydrogen power to X is among the lowest cost to produce zero carbon ammonia. And also, if we look at the cost sensitivity analysis on the right-hand side, it indicates that if the green hydrogen cost is lower than around $1.4 per kilogram, green hydrogen power to X can actually be the most cost benefit route to produce zero carbon ammonia. The same is almost true for methanol production. We can see that in the future, electrification for feedstock and for fuel for methanol production can be one of the most economically feasible routes in the future. If we look at the yellow shaded bars here, which represent the cost for zero carbon methanol production from green hydrogen plus CO2 through power to X, we can see that if we assume a $100 per ton carbon price in the future, the power to X route can actually be way cheaper than conventional route. In some with some lower cost of renewable electricity, the power to X route can even compete with current coal-based methanol cost without carbon price. We also, from our analysis, apart from the technology and economically feasibility, we also look at how might the option of industrial electrification might change upon the potential distribution of decarbonized chemicals production. Right now, the ammonia and methanol production is mainly clustered in those near those coal bases and in a very large-scale coal chemical industrial parks. However, in the future, with the cost reduction of renewable electricity as well as green hydrogen, there might be a redistribution of decarbonized production in China. Take ammonia production as an example, which is shown on the left-hand side. We can see potential zero carbon ammonia clusters rising up. For example, in Yunnan and Sichuan province, which are in the southwest part of China, where abundant hydro power resource is available, we can see some potential pilots for green hydrogen for ammonia production. We can also see some new potential pilots which couple green hydrogen with traditional coal chemical production. And this is also true for zero carbon methanol production. Baofeng has already piloting in green hydrogen use in coal chemicals production. And we are looking forward to more of these pilots coming up in China. Even though we see that industrial electrification is technically and economically feasible in China, and we can also see the resources are available, the current challenges are mainly twofold. First is how can we scale up the practice, especially to tailor with current large-scale production of China's chemical industry. And also we need to think about how can we meet the need of 24/7 centralized production through solutions like large-scale transportation and storage of green hydrogen. Another challenge we need to tackle is how we can accelerate the cost reduction. Right now, some of the technologies are in relatively early stage. So in this regard, we have to ensure the priority in R&D, and also we need to scale up some pilots to reach economies of scale. The transition pathway in this circumstance would include bi-stage expansion, starting with some pilots. Secondly, we will also need to think about how can we combine on-site green hydrogen generation with importing hydrogen, as well as using the grid power to generate hydrogen instead of on-site generation. Thirdly, it is also very interesting to explore the whole value chain collaboration for sustainable business model to tackle the high green premium right now. So all in all, we think that the technology is right there, and there is a promising outlook of cost reduction and the resources available, but we need to think about how to tackle these practical challenges. RMI is going to have an upcoming report to discuss all of the issues we mentioned in more detail. We are about to release our roadmap of China's chemical industry zero carbon transition in March around this year. So we are very much looking forward to more discussions in this session, and we are also very much looking forward to further discussion on the transition for the chemicals industry in the future. Thank you very much.
Thank you, Shuyi Li, for your very interesting and elaborate presentation about all the developments going on, and actually giving us a sneak peek of the interesting insights of the report that's coming up. I wish you all the best with the last details, and I'm looking forward to it. And before we continue to the next speaker, I would like to kindly remind the audience that there's the possibility to ask questions in the Q&A chat option. I've already seen some very interesting questions come by. To all the other panelists who are also watching, feel free to answer questions that are not maybe directly directed at you, but if you know a good answer, you can just respond. There's also translation available, and whenever the translation is added, the question automatically gets sent to the answered category, unfortunately, but that doesn't mean you can't answer anymore. Everybody still has the possibility to answer the question which is originally asked. And some of the questions which might not be answered right now could be answered later during the panel discussion. So once again, thank you, Shuyi Li, for your presentation. And now we move on to our final keynote speaker before we turn to our interactive panel discussion. Reinier Grimbergen, Principal Consultant Business Development at VoltaChem, will present the prerequisites necessary for successful electrifications, the opportunities which can make the biggest impact, and the role VoltaChem plays within this area. Reinier, the floor is yours.
Good afternoon. I'm Reinier Grimbergen, Principal Consultant at TNO, and I'm very glad that I was invited to present and discuss with you the importance of industrial electrification in mitigating climate change. And the title of my presentation is, as you can see, Recarbonizing the Chemical Industry by Electrification, or How the Energy Transition will enable a circular chemical industry. Now, the why for all of this is clear to all of us. On this map, you can see some measurement results from a TNO satellite instrument that can basically measure emissions from space, and it's clear where the big industrial emissions are situated on the globe. And this will, of course, help us to identify where emissions are, and then we can think and act upon how to mitigate them. How then? We feel that there's a very important role to play for electricity, and of course, more specifically, low emission electricity, to enable solutions. So basically, electrification is one of the major routes to decarbonize our energy system and therefore also the industry. The good news, of course, is that the renewable electricity is still going down in price when we talk about wind and solar. And that's good news, specifically in areas where wind and solar intensities are high. But before we proceed, let's first identify for what we are looking at today for the industry, what are in fact the most material or large greenhouse gas emissions globally. And for this presentation, we focus on the chemical industry, process industry. And what you see on the left-hand side is basically the main basic chemicals globally and their production volumes against the emissions. And on the right-hand side, you see how these chemicals relate to the emissions of fuels. And as you can see, bunker fuels, kerosene, gasoline, and diesel have a substantially larger emission compared to the total of the industry, which of course doesn't exclude the industry from taking action. But I think it's important to make clear that how these relations are. Also looking at where should we put our attention to for innovation. So if we look to this impressive graph of emissions, then the question is what is needed to mitigate all these emissions? And we feel that that requires an industrial transformation. And that's a nice word, but then of course you have to think, what does that really mean? And what we have seen in our analysis is, of course, that it is build up this industrial transformation from first and foremost the energy transition, which is about decarbonization by electrification. It's about transport and storage. And then in this presentation, we will focus on hydrogen, but of course, electricity is very important in this category as well. And last but not least, it's about a feedstock transition, and that we call recarbonization by renewable carbon and hydrogen. And that is about the chemicals, because chemicals you cannot decarbonize, because chemicals are based on carbon and will be based on carbon in the future. But the carbon that you use to produce those chemicals should change from fossil into renewable carbon sources. Well, let's then first zoom in on decarbonization. What do we mean by that? What's possible? And if you then look to direct electrification technologies, then that is not it's really basically kind of existing technologies, if you like. So from left to right, industrial e-boilers of course not implemented everywhere yet, but technology is available in short to mid-term. As well as industrial electric heat pumps, which have of course a very high efficiency and which are also available at short mid-term range. And then on the right hand side you see direct electric heating, and then you can think about steam methane reformers or naphtha crackers, stuff like that, high temperature, and many companies are working on that, and we feel that it is a mid-long term technology that will become available. Then another important element of electrification is that if you zoom out, if you produce low emission electricity, then the question is how to apply it in a way that you have the maximum CO2 emission reduction. And what you see here is that at TNO we analyzed this, and then we said, okay, what is then where should you funnel these low emission electrons to what applications to get the highest CO2 emission reduction? And that's first for all is fossil power generation, of course, coal, very important. Secondly, gas power generation. Then space heating, heat pumps is very efficient, of course. Then hydrogen based direct reduction for iron and steel production. And of course, electrical cars, they are very efficient compared to internal combustion engines. If you add it all up for the Netherlands, then we see that for 2030, about 50% emission reduction would require 137 terawatt hours, which is basically a doubling of the electricity generated in the Netherlands today. Well, then last but not least, what you can see on the right hand side in this plot, it's a small diagram, but that hydrogen for the industry is in the merit order, basically not at the highest position. So you should make smart decisions in the timing when to implement technologies to basically follow a path for maximum CO2 emission reduction at the best cost. Well, then we move to hydrogen carriers, to the transport and storage dimension in this graph. And of course, hydrogen is a key energy carrier and an intermediate at the same time for a chemical feedstock. On the right hand side, you see here the chemical side, where you can basically use, for instance, methane in an SMR to produce hydrogen like we do today and to produce ammonia. But you can also use pyrolysis to do that, and then you basically create solid carbon and hydrogen, and you can take it from there. And of course, you can use electrolysis to produce hydrogen and also make chemicals out of that. On the left-hand side, you recognize, of course, the picture of the future of fuels. You can start from wind, solar, renewables, and nuclear to produce your low-emission electricity, do electrolysis, and basically let the hydrogen, the green hydrogen, react with carbon dioxide and then produce the e-methanol, the e-diesel or e-LNG, or the e-kerosene. And if you add nitrogen to it, you can of course produce e-ammonia. Well, then hydrogen is of course expected to be produced most cheaply in areas where the renewable electricity is cheap. And on this geographic map, you can see which those areas are, typically at the equator, and you see on the right hand side a picture of IRENA that shows how future world trade routes for hydrogen and hydrogen carriers could develop over time. Last but not least, on hydrogen, we have technologies to produce it, and that's not only electrolysis. I also want to show here that you can also produce it by pyrolysis, methane pyrolysis, or by mixed waste gasification, or you can add, for instance, for the blue hydrogen, CCS to steam methane reforming to get there. And you see on the right hand side here the expected volume increase or demand increase for hydrogen in the future, and the percentages of which will be green, the other will be mostly blue hydrogen. and you see it also for the different geographic areas. So all these technologies will compete, and we expect that electrolysis will grow only big after 2030, because then there will be enough renewable electricity available to make that happen. And the trade will then develop after that period. Well, then the last topic is about recarbonization. That's about renewable carbon. And renewable carbon sources we can use, which is basically waste or recyclate. It's CO2 and it is biomass. And from all these products and hydrogen, these feedstocks and hydrogen, you can produce the bulk chemicals like ethylene, propylene, methanol, kerosene, diesel, ammonia and urea, but also new bio-based alternatives like formic acid, oxalic acid, furane dicarboxylic acid, or sugar derivatives. This can all be done directly or indirectly by basically power-to-X technologies. And at VoltaChem, we study several of these routes and develop them to higher TRL levels. Then there are also disruptive developments from left to right. Left is plasma pyrolysis on methane. And there you see that in a plasma with relatively favorable energetics, you can turn methane into solid carbon and hydrogen without any emission, or you can turn methane into hydrogen and acetylene as a building block for the chemical industry. In the middle section, you see carbon integrated CO2 conversion. We are working at VoltaChem, which is basically the integration of the capture of CO2 and then converted electrochemically in the capturing solvent directly to usable products for fuels and plastic intermediates. And on the right hand side, you see a very interesting one, which is about turning CO2 with hydrogen electrochemically into formic acid that you can feed to fermentation processes to make basically high value products and even food and feed products. We expect that these novel technologies may disrupt current industries from 2030 and beyond. Then the key takeaways which I would like you to remember from my presentation and which we can discuss in the dialogue later on. First of all, the chemical industry will play a crucial role in industrial transformation. Decarbonization by electrification will be highly important, if not the most important, energy transition pathway. That's of course heavily dependent on the worldwide renewable energy deployment and import and relocation, and of course also elements like nuclear power generation. Hydrogen will be a key energy carrier and intermediate in the industrial electrification, and that will be multiple competing technologies, and we feel that green hydrogen, due to the power that is needed for that, will take off big scale only after 2030. Recarbonization, last but not least, we feel it might prove highly disruptive for materials and fuel sectors, and that's about integrating technologies and new value chains towards 2050 in this area. So a bit later than the energy transition, also the feedstock transition will start to become big. Last but not least, and there is my closing remark, at VoltaChem we provide a collaboration platform, open innovation platform for system understanding and for disruptive developments that I showed during this presentation, and I'm happy to discuss with you individually on opportunities that we can see to collaborate and speed up and accelerate industrial electrification to basically for a better world and to mitigate climate change. Thanks for your attention and looking forward to our discussion later this afternoon.
Thank you very much, Reinier Grimberg, for this interesting and in-depth overview of the prerequisites, opportunities, and the role of also VoltaChem in this process, and also for being very realistic about the possibilities and the timelines being used with all the new technologies that you went over. Before we now move over to the interactive panel discussion, I wish to once again thank all the speakers for their great insights and their nice presentations. in the past 45 minutes. And I want to mention one more time that we have the panel discussion with simultaneous translations in both English and Chinese, so please make use of that. And now let's go over to introducing the panel speakers of this afternoon, or this morning, wherever you're located. Our panel discussion consists of 6 experts from all over the industrial electrification sector. We are joined by Jacqueline Vaassen, chair of the board of the Top Sector Chemistry in the Netherlands. We have Mr. Li, Deputy Director of the Department of Industrial Development of the China Petroleum and Chemical Industry Federation, who also just did a great opening speech. We have Santos Wang, Senior Manager, Senior Manager Climate Change and Energy at DSM China. Yingping Chan, he is a professor at the Tsinghua University. And at last, I'd like to welcome 2 familiar faces in Xuyi Li, Manager of Industry Decarbonization at RMI China, and Reinier Grimberger, who just also gave a speech, Principal Consultant Business Development at VoltaChem. And hopefully these speeches will translate into a fruitful panel discussion. Also, to just mention it one more time, as we haven't done it enough, if you have any questions during the panel discussion, please write them down in the Q&A section, and we hope to give the answers of the questions during the live panel discussions, and some of the questions might be answered in the chat itself. Also, for the panelists, if you are not having the word, please take a look at the chat, see if there are any questions you might be able to answer, and please do so. All right. We've prepared a few questions for the panelists, also based on some questions we got beforehand from some of the audience, and we would like to give also every panelist at least the opportunity to give their insights. So without further ado, let's start with the discussion. I'd like to start with a question for Yingping Chan. I'd like to start, because I'd like to have some more insight in the Chinese developments that are going on industrial electrification. Eric Appelman from Brightlands Chemelot campus just gave us some great insights into their campus and the technologies they are working on. And you yourself, you do research on the economics and ecological impact of the chemical industry parks and the eco-industrial parks. What is happening in China, in China's industrial parks on electrifications, and what are the best ways to measure and monitor this?
Well, good morning and good afternoon. I'm Jinping from Tsinghua University, and this is a good question, I think, and also thanks for the invitation. At first, I would like to give you a brief introduction on my research. So my academic area is industry ecology, and mainly targeting on the eco-industrial park, greenhouse gas emission mitigation in Chinese industrial parks. So my group has a long-term cooperation with a lot of very typical chemical industrial parks in China. And I also have worked in one of the largest fine chemical industrial parks in the Shaoxing city for more than 16 years. So in light of the question, so what is happening in China's industrial parks? There are some big numbers for the industrial parks in China. So the first one is the 2,500. So it means that China have more than 2,500 national level and provincial level industrial parks. All these parks are based on research in my group. They contributed more than 31% of the greenhouse gas emissions in China. And all these industrial parks contributed for more than 50% of the gross industrial output values in China. So you can think that industrial parks in China, they are playing a very crucial role on economic development. Meanwhile, they also have an intensive carbon footprint. So That's why the central government has attached great importance on facilitating eco-transformation and low carbon development targeting the industrial parks. So this is the background. As mentioned in the opening remarks by Mr. Yun Liang, that at the end of year 2021, the State Council released a very important document, the Action Plan for Carbon Dioxide Peaking before 2030. In this document, a list of tasks has been proposed for the Chinese industrial parks, such as the energy conservation and carbon reduction projects. The key measures include promoting systematic optimization of the energy system and also the cascading utilization of energy. So I think that reading the level of industrial electrification is also proposed in the action plan by the central government. Okay, for the industrial parks, I think electrification will play a very important role. So based on my research, so averagely speaking, more than 55% of greenhouse gas emission from industrial parks are coming from energy infrastructure such like electricity generation, combined heat and power, and also the steam generation. It means that 75% of the greenhouse gas emissions coming from energy infrastructure. Another number is that more than 84% of the energy infrastructure in Chinese industrial parks, they are co-fired infrastructures. So that's why one of the key countermeasures in industrial parks to facilitate greenhouse gas mitigation is to decarbonize the energy infrastructure. So I think that if electrification could be implemented widely in industrial parks, in particular to replace the steam generation, I think there will be a promising potential for. There will be a promising potential of energy saving in industrial parks. Also, I'd like to see that there is a new trend in Chinese industrial park.
Santos, sorry to interrupt. Could you please round up your answer? It's very in-depth and that's nice, but we also like to go to the next questions later. And I also see that Rainier, I think, wants to respond maybe to the Dutch developments. So if you could share your last thoughts and then we could go on, and then later maybe we can come back to this topic.
Thank you.
Thank you. Sorry. Okay. Thank you, Santos, for your very clear answer. Rainier, I saw you unmute your mic, I think, or was that not the case? If so, maybe you would like to respond from a Dutch policy perspective.
Yeah, I can. I'm happy to do so. I clearly recognize what the previous speaker says, that for the industry parks, electrification is one of the main routes towards decarbonization. In general, it is for the total energy system. However, the challenge is that if we also going to do big on hydrogen, then you get additional demand on renewables, where renewables are today already scarce. So we are basically blowing up the need for green electricity or low emission electricity if we add too many hydrogen applications to it. And in my personal view, we should be very careful with that. So really look in the end, that's what I try to convey in my presentation, to a kind of electrification merit order. So how do we reduce the CO2 emissions in the best effective way, using the least amount of kilowatt hours of electricity? And I think that's the name of the game that we are all in. And that requires a kind of priority setting and timing of new technologies in combination with the buildup of low emission power generation. And that determines your timing. If you go faster than the low emission power generation develops, then in fact you will increase greenhouse gas emissions instead of decreasing them. So it's crucial to all of us that this is a timing game, and to make that transparent and joint insights on this, I think is crucial for us as global citizens to basically drill down the greenhouse gas emissions both in time, but also in the economic best possible way. That is my main message. And then what VoltaChem can do, that's I think final words, is we work really practically. So we work practically in the sense that we give advice on road mapping for this, what I just explained. We can help you with that, combining the energy and the feedstock transition, because that is what chemists do. They are very good at that because they are related. And we can help you with specific technology developments. And our focus at VoltaChem is on next generation electrolyzers. So really improve the stack performance and lifetime of stacks of electrolyzers, which will be crucial for green hydrogen. Secondly, power to chemicals. That's direct electrochemical conversion without hydrogen. Very important, takes a bit more time because the technology is not so mature like electrolysis. And the last one is upcoming power to X, and also Eric Appelman. We collaborate with Brightside at Chemelot on developing this electrical plasma technology to basically convert natural gas or shale gas into both hydrogen and big time feedstock for the chemical industry, carbon feedstocks without any emission. So I think those are the highlights that we are practically working on. And yeah, feel free to contact me or my colleagues on these topics outside of this meeting, of course, if you have an interest to have more information.
Thanks, Reinier, for this elaborate response. Yen-Bin, maybe a very short response from your side to this, the topics mentioned by Reinier, just if you're interested. Oh, sorry, I don't see you. Yeah, there you go.
So you mean the question proposed by the research ongoing in China on oxy-combustion of coal or other fuels in combined with CCS?
Yeah, I thought maybe you had a short response to Renier's insights to get the discussion going, so to say.
So, well, for the electrification, I think also the green hydrogen, because we talked too much about the electrification and green hydrogen in the petrochemicals. I think it's there will be very promising. But as for the most of the such like in China, most of the chemical industrial parks, this for example, they are mailing the fine chemicals, small and medium fine chemicals. So the use of the electrification and green hydrogen, it could be some challenges, in particular for the high cost for the electrification, in particular for the radioactive and also for the such like the high advanced technology. So I think it depends on the client of the electrification technology. Okay, that's my response. Thank you.
Nice, nice. Thank you very much, Yupin. Maybe I was also wondering, we have one of the companies with us, Santos Wang from DSM. Maybe you could tell us a little bit more about the things you've just heard, and also about the technologies that DSM is working with on the field of electrification.
Yes, can you hear me?
Yes, we can hear you.
Okay, let me start. Hello, everyone. I'm Santos, and my position is Senior Climate Change and Energy Manager of DSM China region. And currently, my responsibility is for the GHG reduction program running of our around 20 Chinese sites. And for the other region, my colleague also working on that. And we are one of the few companies to achieve the A rating. It's the top leading position from the CDP. It's from the carbon disclosure project. And after several years, GHG program running, last year we updated our GHG target from the 30% to the 50% in 2030. And for the electrification topic today, we always focus on in our past, because renewable steam is much harder to get than the renewable electricity. So far in our around 20 sites, only have one site nearby we have the source for the renewable steam. And based on our previous experience, and we see two electrification applications in the chemical industry we can use later. The first is about for the current chiller. Based on some history, maybe it's based on some history reason, some sites still use the lithogram chiller. It's driven by steam in the past. And for the electric chiller, combustion chiller, it had much high efficiency. For the COP is such like more than 5 times. And as you know, in the last year, 2021, so steam price increased a lot, maybe 30% more in the China. And for the electricity only increased a little bit, maybe maximum 10%. And for that means if with high energy efficiency and use the electric chiller to instead of a steam drive chiller, we have very good business case there. And but one thing also need to mention here is don't forget the refrigerant, because refrigerant loss is also one emission source. And currently in last year, our DSM provide one standard for our internally. We can use must need to use the low GWP value refrigerant when we change the chiller from the lithogram chiller to the electric chiller. It's very hard because in some region like in Europe and in America and in China later, some refrigerant already forbid and also forbid soon. So we need to consider this. And secondly, for another electrification application is for the evaporation and the distillation, because as you know, the evaporation and the distillation is also big energy user in all the chemical plants. And we found that the MVR and the heat pump can replace the traditional steam evaporation in most scenarios. And at the same time, we can save more than 80% carbon emission with high efficiency. And so when we work at the DCM, we have also a lot of projects running about these two areas and all those experience. So if you are interested in that, we can maybe communicate and exchange some information offline later. Okay, that's for my part.
Thank you, Santos, for your also a very elaborate answer, and just also it's also nice to have a good insight about the business-related impact, the pilots and projects running now, and the possibilities that are actually already getting started. So I am also wondering, we've now heard a lot of technologies come by and the next steps that have to be taken. What can be done from a policy perspective? So I'd like to approach Jacqueline Vase from that. Jacqueline, you represent the top sector chemistry in the Netherlands, and I thought maybe we've already heard a little bit about the current trends in the Netherlands and what should be done, but could you maybe give some insights from a policy perspective of what you think the government can do as a first step, or how it can support this sector? And also what the role of international collaboration could mean in this regard.
Yes, thanks for having me on this panel. A pleasure to be here. If we look at the Netherlands, we started out with the Paris goals to reach climate neutrality in 2050. And based on that, we have agreed on a climate agreement in 2019, which was undersigned by a lot of parties from the national government, local governments, industries, NGOs, and very big consortium. And in this climate agreement, there was stated that electrification of the industry is an important part to reach our goals. So the government has asked for a roadmap towards electrification of the industry, and that has been presented but is also publicly available, and it sketches the steps that have to be taken before 2030, before 2050. But we're facing an enormous challenge. If we're looking at the energy consumption in the Netherlands last year, our primary energy use was 2,940 petajoules, of which 10% was renewable, 44% natural gas, and 37% oil. So we still have a long way to go, because electrification of the industry means a large increase in the energy consumption. So we have to invest a lot in renewable energy. And that's what the roadmap is looking at, especially wind at sea, which will become a very, very important part of the energy mix. But if we're looking at electricity, it's very difficult to store electrons, especially if you make them at sea, and it's very expensive, especially when you go further offshore to transport them to shore. And also the loss of energy of transporting electrons is much higher for molecules. So we're also investigating how can we make renewable energy and transform it into energy carriers, for example, hydrogen. And at the moment, we're having our first, in the Netherlands, a first offshore pilot of a 1 megawatt electrolyzer. So it's still very small, but it's an important step. It's placed on an existing oil and gas platform in the North Sea. But it's a very important step to test current electrolyzer technologies in offshore conditions and form a prerequisite for innovation for that. As I said, we're also looking at transforming electricity into energy carriers, and therefore
I think you're in the same problem.
Sorry. And therefore, the government has erected electrochemical conversion and materials platform. It's a combined effort of 3 top sectors: chemistry, energy, and high-tech systems. And it consists of 16 national experts, which coordinate the R&D development within electrochemical conversion. Nice examples of that ECCM platform of concrete projects are the Field Lab Industrial Electrification by VoltaChem, of which Rainier can tell you everything if you need to have more, and the Megawatt Test Center of Hydrogen, which has been erected by ISPT. Electrification is important, but it's not the only step towards reaching carbon neutrality in the industry. And therefore, we're also looking at, for example, plastics recycling to see if we can recycle plastics into the virgin monomers, which can be used again into the process. Because if you can reuse them, you don't need either fossil or renewable fuels to make them. And we're also looking at bio-based feedstocks. And for the first part, looking at recycling of plastics, we're mainly looking at the assets, the knowledge, and the cash of the existing companies. But if we're looking at the bio-based, our special focus is on the SMEs and the scale-ups, which can lead to disruptive innovations. We're also working from the top sector on our international focus. Due to COVID, it has been a little bit quiet the past years, but we now see also the possibilities of these webinars, which make it easier to connect with all over the world. But we are looking at where are the priority areas to collaborate. And I'm very happy to say that we're intensifying our collaboration with the Innovation Attaché Network at the Embassy to help us prioritize where the most beneficial opportunities abroad are. But we still have to face working together with everywhere along the world, as we're already facing a huge problem fulfilling all the vacancies. So we cannot afford not having talent from all over the world join our ambitious programs. I hope that explains a lot. It explains a bit about our focus.
Definitely, Jacqueline. Thank you very much for this answer. And I do think like that we're making good progress, but also that we have a long road ahead, which we have to focus on. But it's a nice first step that the plans are there and the first steps are being taken to actually develop those plans. That's good. I'd like to go to the next speaker, Rainier. I saw your hand earlier, so I'd like to first go to Yang Li and then come back to you just for I think you want to respond to Santos from DSM. So I'll come back to you a little bit later, but I'd like to see from a Chinese policy side via Yang Li what the Chinese insights are on this and what just been said by Jacqueline, and also if the government is kickstarting this economy and the industrial electrification from a policy side, where they should start and what is the first step that China is taking right now.
好的，其实您提的这个问题，我们这边也一直在思考。
So the question you just mentioned, we have also been considering it as well from an association of the industry. We have been discussing with the government as well for the first step. Currently, there are two directions.
那么一个呢，就是在一些涉及到比如说需要这种热量的，比如说像这种加热炉，那么在这方面来讲的话呢，可能是作为电气化研发的一个比较好的一个启动点。目前呢，我们也看到的一些这个项目，那么在提出相应的电气化或者说是低碳的这么一个方案里头呢，都是涉及到这个加热方面进行部分的这种电气化的这种替换。那么在这方面呢，有几个这种项目。 这是属于可能是一点吧。比如说，我举一个例子，像在烯烃生产过程中，那么这里边涉及到一些这个就是加热炉、裂解炉这方面的，那么可能是作为一个切入点。那么现在有几个项目呢，也在提出了这个工作的这个方向。那么这是第一个。第二个呢，就是与节约能源相关的。因为在某些的这个应用场景，如果用电气化来讲的话呢，是可以显著的提升它的这个能效水平的。在这方面来讲的话呢，一些这个终端的治理或者是终端的能效的提升的项目，可能是作为一个比较好的一个切入点。但是现在来讲的话呢，需要对于前面一个切入点需要解决的一个非常现实的问题，就是跟企业所在地方的电网的一个匹配的一个问题。 因为这个需要的这个用电的这个增量和这个负荷的冲击来讲的话呢，对于当地的电网是一个比较大的一个挑战。是这样，后边一种来讲的话呢，是马上可以动起来的。目前讨论的主要是这两个方面。主持人。
Thank you, Yang Li. For this nice answer, and also good that the steps that you are mentioning are also already so concrete in this stage that really helps to get it going, and it's not just words but actual actions going on. Now I'd like to maybe give Rainier the word. I think it's in response to Santos' answer earlier about the developments going on at DSM. But Rainier, if you also want to respond to the other answers by the other speakers, feel free to do so.
Yeah, so what I just wanted to bring up is how is the situation in China when it comes to get access to low emission electricity? Huh? How is it also foreseen that it will become available for the industry locally? That's one. And the other side is the feedstock side. How do you look at the availability of circular feedstock? And circular feedstock, in my view, is CO2, of course, but it is also biomass, which is in China maybe also challenging, I don't know. And of course, waste, so plastic waste, etc. What Jacqueline also mentioned, we look a lot in the Netherlands to circularity, and because we are a small country, we are population dense. We are more like a city from, I think, seen from China, and that is with a few parks in between. And that's where we have this industry, and we need to basically close all these loops. And there's a lot of innovation ongoing in the Netherlands. So I see two main challenges. On the energy side, availability of high availability of low emission electricity. And on the other side, the availability of, let's call it now for this discussion, circular carbon, being CO2, biomass and waste. So how is that situation for China? How do you look at that challenge? That would be my question. And if I may make a final remark, I think that might be an interesting area where we can also help each other, of course.
I think that's definitely the case, especially. I thought maybe Shui, could you give some insight on this? Maybe with the report we spoke earlier also about the power grid and how this has to be handled. Maybe you know a little bit better how what the situation is currently in China.
Yeah, sure. And thank you very much, Rainier, for raising this very interesting question. And this is actually what we've been discussing when we are developing our decarbonization roadmap for chemicals industry in China. So the first one is regarding the availability of low carbon electricity. We actually had a calculation, especially in China's case. If we are to have one example is the methanol production as large scale as around 1 million ton. So that would require about 6 gigaton level of electrolyzers, and that would be a very large scale requirement of electricity. So, and also a large requirement of land, of course. So that brings us to the solution of, and I do totally agree to your previous point about the pace of developing green hydrogen. So maybe at the very first place, as intermediate solutions, we might need a combination of on-site generation together with grid power, or maybe a mixture of other solutions like carbon capture. So I do echo to your point. And your second point is about the CO2 utilization. We do see that in, for example, the chemicals industry, we have relatively higher concentration of CO2, which means that we can have a cost-effective flow if we utilize this part.
Yeah,
and
specifically,
so,
if I may interrupt you, specifically for the big ammonia, where you have
absolutely.
You have concentrated CO2 in your hands, so.
Yeah, definitely. So actually, we are seeing pilots in China right now, starting by using industrial exhausted CO2, and maybe at the very first place with a byproduct hydrogen, but we can see that in the future we can transform to green hydrogen. But of course, we think that the largest challenges would still be the green hydrogen, and given that the solar and wind resources in China is concentrated in the north and west area, so we assume that there might be a scenario that there might be some kind of capacity redistribution in China in a zero carbon scenario, which we find is very interesting as well. So we look forward to more discussion with you on this.
Yeah, super.
Offline.
Thanks for your answer. I've maybe one, if I am allowed, one question on the regulation side. You know, in Europe we have the Fit for 55, so we really have stringent targets as well as an ETS system, this emission trading system for CO2 emissions, which is now at a record high of about 90 euros a ton already. I think this is not operational in China, right? Such a system. Or can you comment on how China is looking to Europe, if you like, on what is happening here and how you translate that back to your situation looking forward?
Yeah, if I could just briefly give a shot, I don't know whether Mr. Yongliang can give more comment on the policy side. So right now, the chemicals industry are not yet included into the carbon trading system, but it is among the several sectors that would be about to be included. So of course, carbon price would be an external constraint. To lower the green premium. Yeah.
Actually, personally, I think if you don't put it in place, nothing will change. To be a bit blunt.
Yeah.
Because basically the economics don't work. Huh? So that's just a fact.
Well, maybe it's interesting for Yongliang Li to respond to this.
好的，刚才舒一这边提到了就是碳交易这一块儿，那么中国目前的碳市场只是囊括了发电行业这一个，当然这里边也涉及到石化化工的一些企业，它的这个自有的电厂也囊括进来了，但是主体还没有进来，目前有7个行业是后面会陆续的进到全国的碳市场里头，包括我们石化化工行业，当然也包括像建筑材料。像钢铁等等这种碳排放量比较高的行业，但是从目前的这个进度上来讲的话呢，可能是要逐步的纳入。我个人判断呢，石化化工行业可能还要有一个2、3年的时间才会纳入到全国的碳市场里头。如果按照正常的节奏来走的话，但这样来讲的话呢，确确实实，因为对于碳的这个价格没有一个。就是表示的话，没有一个显示的话呢，在企业投资也好，或者是在它的经营策略上来讲的话呢，那么对于这方面的成本，它可能会忽略掉。这个对于我们这个电气化以及降碳来讲的话呢是不利的。前面专家提到的，我非常的赞同，我们必须现在马上行动起来，要开展相关的一些工作。刚才如果我们做一个广义上的一个阐述的话呢，不仅仅是如果我们最终是这个用的这个电是一个低碳电力的话呢，其实还有一条路子是现在已经在开展的，就是我们光伏或者是风能发出来的这个绿电，然后去电解水制氢，然后把氢气补到我们的石化系统里头去，那么这样替代一部分化石能源制氢，这样也会降低整体的碳排放。那么在这一块来讲的话呢，像在中国的宁夏、内蒙、新疆都有相关的这种示范项目在开展，而且目前的这个示范项目的规模来讲的话呢，也是有一定的这个体量的。那么这个也算是一种广义上的这种电气化，因为它的这个用能的源头是来源于可再生能源的电力。我做这么一个补充，主持人。
Thanks.
Thank you very much, Yongliang, for your very elaborate response. It's also nice to get some insights from a policy perspective and governmental perspective. I also saw the hand raised by Santos Wang from DSM.
Yes.
Would you like to still like to respond to this?
I have something to add. Yes, I have something to add. Currently in Chinese, carbon price is so cheap, it's like 45 RMB per ton. But in our internally DSM insight, we have internal carbon price is 100 euro per tons. And beside that, we also have independent GHG funding every year, 20 million euro. That's also good by can generate some good opportunity for the GHG reduction ourselves. It's all good for the company too. And not wait for the government. We can just by ourselves do the GHG reduction. That's our in last.
Thank you, Santos. Anyone who wants to respond, feel free to do so. Otherwise, I would like to have like a question for Xiu Li from RMI about the possibilities for international collaboration, as RMI has been also. Oh, I see. Sorry, 1 second. I saw a hand raised by Yingping, so feel free to respond, and then later on I'll go to Xiu Li.
Okay, a quick response to the question by Renee about the availability of low carbon electricity. So besides all the comments that one of the key practice in China is the deployment of large size and high energy efficiency coal-fired power plant, and also the high voltage direct current from North China to East China. So that will be very effective to reduce the carbon intensity of the electricity. So that's a short response for the question by Renee. That's all. Thank you.
If I just may quickly react, thanks for that. So you say you have high voltage direct current connections for larger distances in place to transport big amounts of renewable electricity, right?
A combination of the coal-fired electricity and the renewable electricity. It's a combination.
Okay, thanks.
Thanks both, and thanks for the reaction to everybody. But also, like I said earlier, I'd like to ask a little bit more about the international collaboration. And I think Shui, with your RMI perspective, and also the knowledge about the other energy sectors, where do you see the possibilities for collaborations within this sector? And would it be possible now, or do we have to wait? So maybe you could give some insights on this topic.
Yeah, sure. Thank you, Tom. I think maybe this is also an add-on to Song Tao's point on how pioneer companies can add to the efforts. I think that we now stand on where challenges are there and momentum is also set up. So we do see opportunities in international cooperation, maybe starting from peer learning among key stakeholders. RMI is actually, right now, we are supporting communication and peer learning between China's decarbonization pioneers and the global champions. And we are targeting the state-owned enterprises in China right now, who oftentimes dominate not only domestic, but also international markets. Just take the steel industry, for example, like Baowu is the world's biggest crude steel producer, and 9 additional Chinese steel makers are in the world's top 20. And most of them are state-owned enterprises. And this also holds true for other major heavy industries. And we also now see increasing number of the SOEs making carbon peaking and neutrality related commitments. And this includes China's 3 giant oil and gas companies, Sinopec, CNPC, CNOOC. And we also see leading coal chemicals companies exploring green hydrogen plug-in with chemicals production. And through our engagement, we do see that these leading companies are more willing than ever to learn about international best practices. And actually some of China's experience is actually leading the way. So we are right now working to foster international peer learning between Chinese leading players and global champions. And but the potential areas could include experience in effective target setting, roadmap development, corporate governance and carbon asset management, and also how to get ready for potential policies and so on. And so in this regard, we are hoping to get more stakeholders on board to make this dialogue happen. And I think the platform like today's webinar is a very good practice as well. And I think maybe in the content area, as we've already touched upon some of the points, it's very interesting for both sides to discuss the practical solutions on issues like the pace of green hydrogen development, and also the solutions with integration of with other zero carbon technologies as well. So those are a few of my key points. Thank you.
Thank you, thank you. I think that those are some very important key points, and it gives a good position of where and how we could collaborate. And I'm happy to hear that this today's webinar is also part of this collaboration. And maybe in that regard, we can answer some questions from the public, from the Q&A that have been asked earlier in this webinar. If there are any other audience members that like to ask questions, please do so. Because let me go to one of the questions I saw was quite interesting about Jane. Jane asked about the thoughts on the hydrogen burning steam crackers. They run on green hydrogen instead of electrical steam crackers, and if it's cheaper to retrofit existing crackers with a hydrogen burner than it is to build a completely new electric cracker. And hydrogen burners are available today as a technology, whereas electric crackers are still in the research and development phase. Is there anybody who would like to respond to these questions to give some of your insights or your own thoughts?
Yeah, I can. Oh, Jacqueline, go ahead.
Okay, yeah, you can also go ahead. The point is that at the moment we don't have enough hydrogen to feed the hydrogen burners, and the loss of electricity. If you make hydrogen, especially out of gray electricity, where you still emit the CO2 emissions, the efficiency is too low to make it a viable business case. Renier, maybe you want to add to that?
Yeah, I've looked into these schemes quite intensively, and one of the options that some companies indicate they try is to use fuel gases from crackers to convert that into basically hydrogen and do CCS on it. So basically put an SMR, ATR on your fuel gases and then funnel the hydrogen from that into as a fuel. And then you basically decarbonize the fuel of your cracker in situ. But I'm not an expert in that area in the sense that I don't know how the energy balance then is, how much hydrogen you could then produce. But that is what I hear that some companies are exploring. As a kind of in-between option. So it's a very good question, and I think it's one of the options for crackers to greenify crackers, if you like.
There is actually a technology that is coming close, an ethane cracker.
Yeah.
Basically fired on waste hydrogen.
Yeah. That is I think the project that INEOS is now has announced.
No, that's the standard in the US and in the Middle East. They are essentially hydrogen-fired crackers.
Yeah.
So it is. You can buy it. It's there. It's economical.
Yeah. Yeah, because then you basically produce ethylene and hydrogen in one step, and with cheap shale gas. Huh? So it's economically also attractive.
Yeah. Thank you. Also, Eric, for your contribution. That's very nice. Thank you very much. I see a different question in the chat. It's more related to a slightly different topic, but still relevant. How can digitalization accelerate the transition towards electrifications? Maybe anyone has some insights of this?
Can you repeat that, please? What can help?
The digitalization.
Oh, digitalization, yeah.
Accelerate the transition towards electrification. If not, then
I think it could. If I may react, in my view, it could in the sense that if you think about smart grids, which needs to be steered and to be controlled, I can imagine that there can be a place for digitization, serious place for digitization. Sorry, for that.
All right, thanks, Eric. I see you have your hand raised.
Yes, I actually raised a question in the chat. It's a bit related. We also talk, of course, about decarbonization by CCS, and I saw some good contributions. It is a bit tricky, of course, if you take the exhaust gas of a conventional coal-fired plant. But I have personally been fascinated by the topic of oxy-combustion. It is not so difficult to make reasonably pure oxygen, as we actually see for medical purposes even. You can have a concentrator at home for your own benefit. That would, of course, simplify the task to do a CCS on a coal-fired plant tremendously. And now the Netherlands are not exactly famous for doing research on coal combustion, I think, but I think China will be very much at the forefront. I would be extremely interested to learn about a center of excellence around oxy-combustion. Is that such a thing existing in China?
Yinping, maybe you would like to respond?
Yes, so the last question is about digitalization. Is that true? Digitalization.
No, it's not digitalization. This is about oxy-combustion. This is about combusting coal with pure oxygen rather than with air.
Okay, I will take put my hand there. Okay. If it's digitalization, I'd like to add more words, but if it's not, so I will give up. Thank you.
All right. I'll come back to you a little bit later, Yinping, but let me maybe Shui, I saw you raise your hand. Was that in regarding the question of Eric?
Yes, I know that in China, an organization called Agenda 21, and also together with the Ministry of Science and Technology, have released the roadmap of CCS in China last year and the year before last. And one quick figure that I adopted is for high concentration CCS. And I think maybe it is also the case with, oxy combustion to get a high concentration, while the cost of whole value chain CCS is around like more than $50 per ton of CO2, and it can actually be lowered to around $15 per ton CO2 for the whole value chain. So this is mainly due to the cost reduction of the capture part of it. Yeah, I can send over the material if that is helpful.
Would be very appreciated. Yes, thank you. Thank you.
Yeah.
If you then can please copy me in as well, it also has my interest.
Yeah, sure.
I'll copy you in,
I'll look for whether there is an English version of that and share.
Thank you. And if you don't have the context, we can also share it via the Innovation Network. And yeah, we'll also share this recording later, by the way. We told this earlier, but just a reminder. I thought maybe Yinping, you could come back to the question about the digitalization, give your input about that.
So you mean the digitalization?
Yeah, you mentioned that you had also had an answer to that, or had some input. Okay, so we talked about the electrification and something happening in the Chinese industrial park. So in particular in chemical industrial park, during the last maybe 3 or 4 years, there is a new trend is digitalization of the chemical industrial park. Also in China, we called smart chemical industrial parks. It means it's a two-level system. First one is digitalization of the chemical manufacturers by integrating all the process parameters, energy consumption, and such like pressure, temperature, and industrial gas consumption, all such things, and also the cooling flow, such like the cooling water or some other cooling materials, integrating all the information together, and then the chemical manufacturer would like to develop a data-driven decision-making system to find out the risks or the early warning of the pollution. So that's one of the trend in Chinese chemical industrial park, in particular in some large-scale chemical parks. We call the smart chemical industrial park. Another level is the system developed by the government in the chemical industrial park. They also call the smart platform
by integrating some common information, such like energy consumption, steam consumption, pollutant emission, all such things integrating together. Also, the CCTV in the chemical industrial park, by integrating all the materials and the information together, help the decision makers to prevent the safety risk and environmental pollutions. So that's my words on the new trend in Chinese chemical industrial park for digitalization. Okay.
Hello, do you hear
Hello?
me?
Tom, I think your
Tom,
microphone is not working
we don't
correctly.
have sound. Yeah.
We'll be back soon, I hope. No, not yet. Let's see if we can mute and unmute you. That helps.
Can you hear me now?
Yeah.
Yes, thanks.
Yeah. Okay, great. I was gonna say thank you, Jinping, for that elaborate answer, and nice to see that digitalization is coming back to such a big extent, even in industrial parks. I thought maybe as a closer of today, we heard a lot of questions to the Chinese speakers from the Dutch panelists about what is happening and the developments. Maybe there are some questions from the Chinese panelists to the Dutch panelists about the situation in the Netherlands, and if not, maybe we have time for one small question. But please let me know if you have a question to the Dutch panelists. If that's not the case, then maybe still the other way around. If any of the other panelists have a question for either each other or just in random, just throw something into the group, just let it know. And otherwise, we'll close up as the 2 hours are almost over. All right. That's pretty clear. In that case, I'd like to thank all the speakers and the panelists for joining this webinar, and also for having their very insightful, in-depth questions and answer to all the and a fruitful discussion we've just had at the end. I think that shows that there's a lot of things happening, a lot of new technologies, but to a certain extent, we're all on the same page. We kind of know where we're going. We may be walking in different routes, but the end goal is the same, which I suppose it's nice. And it's also great to see that we're all working on this on a research level, economic level, and also on the policy level. So I want to thank everybody for showing up today, and I want to thank the audience for staying till the end. If there are any more questions or you want to have some follow-up, or just let us know, and we can provide you with the recordings of this presentation. And we can also bring, of course, parties in contact with each other if you want to know more about a certain panelist or speaker that has spoken today. So I want to thank you all for joining, and I wish you either a good morning or a good day, or for the Chinese, hopefully a short day to go home afterwards. So goodbye, and we'll stay in contact.
Okay, thank you very much. Bye-bye.
Thank you.
Happy New Year.
Thank
to the
you.
Chinese.
Yeah.
Bye now.
Bye-bye.
Thank
Have a nice
you.
day.